Heidi-ho, neighbors! This is section 2.4 on the graph of y equals kx. Mostly review today. I think you'll like this section a lot. Here is your journal choice. You can submit it online if you want on Edmodo, or you can write it out if you are old school. Okay, here we go. Objective and what's the point? We are going to review graphs of lines through the origin and the idea of slope. We're going to find slopes and rates of change, identify some properties of variation functions, graph variation equations, and identify variation equations from their graphs. Slopes and rates of change is essential to understanding when making predictions and finding trends, and that's pretty much the whole gist of the chapter. We're all about making predictions this chapter, and slope really helps us do that. So, words to know, here are some examples. Rate of change. This is going to be the new word for you. You're going to hear this all the time when you're in calculus. Rate of change is pretty much the new slope. It's how y changes with respect to x. It's another name for slope. The reason in the past you've used slope all the time is slope only works on lines. Okay? Rate of change works with any relationship. So that's the big difference there. This works with any relationship, slope only works with lines, but the process of finding a rate of change and slope are the same. And you'll learn a lot about that this chapter. Okay, slope is a measurement. Slope is a way to distinguish one line from another. Otherwise, all lines are the same. So the way we distinguish one line from another is by talking about its slope. That's saying what is its orientation, what is its steepness. Okay, I think everyone, when I say slope, immediately says rise over run. Okay, this is where you get a little wishy-washy. You sometimes forget what you're supposed to do here. If you remember rise over run and you think of rise spelled this way, R-Y-S-E, you'll never forget that y goes on top and x goes on bottom. Okay, this means delta y, change in y over change in x. If you remember change in y over change in x, this formula is not quite as important, the y2 minus y1 over x2 minus x1, because that is the change in y. This is the change in x. And that's how you find slope. Okay, you've all used that formula before. Like I said, this is review. The only thing new on this slide really is that concept of rate of change, which works for any graph, not just the line. Okay, for the graph of direct variation function, the equation y equals kx has constant slope k. Where have you seen this before? So they're saying if you have y equals kx, where it's direct with no exponent here, this is your slope. You should all be saying right now, well, duh. This looks just like y equals mx plus b, except b is 0. So then I just have y equals mx. So k and m are the same thing here. And that's exactly right. Your slope and your variation constant are the same in the situation of y equals kx. So that's what makes y equals kx a special direct variation relationship. Okay, you've done this before. What is the slope of a line through the points? 963 and 25, 100. Okay, they're asking for slope, so they're asking for change in y over change in x. Or you could do the formula y2 minus y1 over x2 minus x1. If you're curious what the answer is, I want to skip over this. I got 37 over 16 in case you're wondering. I forget. I'm supposed to tell you the answers first these days. Okay, so let's finish this up. I have x1, y1 for the first point. The first point gets the 1s. The second point gets the 2s. So now I have y2, 100, minus y1, which is 63, all over 25 minus 9. And of course this wouldn't work out nicely. 100 minus 63 is 37. 25 minus 9 is 16. That does not simplify, so that is my slope. If you could simplify it, please do. Never, ever, ever give me an improper fraction that does, don't ever give me a mixed number. That does me no good. I want the improper fraction. Determine the slope of a line with equation d equals 5/7 w, where w is talking about weeks and d is talking about days. There's no work here. This is right in the form y equals kx. I don't need to graph it. I don't need to do anything. dy wx. What's my slope? K. What's my slope? 5/7. Isn't that easy? I know. It's awesome. All right, moving right along. We are going to do an activity in class. These are the important notes you should get after we do this activity, okay? When you graph lines, and you should have all this from your algebra days, positive slope looks like an uphill line. And the bigger the slope, when I say bigger, like the larger the number, the steeper the line. So this slope here has much bigger number or value than this slope because this is steeper. So that will be a larger number. And it's definitely going to be positive because it's uphill. This would be a smaller number. When I say smaller, I mean smaller as in close to 0. 0 is that neutral line. It's what changes from the negative to the positive. So these are all positive slopes, positive slope, positive slope. When do I get to 0? Well, pretend this is perfect. I know it's going to be hard for you to print. Oh my God, when I try to do it slow, that's horrible. It's so bad. That's actually negative slope. But if it was completely horizontal, then it would be 0, because after that, then we start going to downhill. Okay? Negative slope looks like a downhill line. So here's some negative slopes. Negative, negative, downhill. Like if you put, I call him Mo the slope man. Mo the slope man would be walking downhill. He always walks left to right like you read. He's walking uphill here, so that's positive. Downhill, negative. Okay? When he's walking flat, that's when it's 0. That's when it's 0. You do need to know all direct variation passes through the origin, no matter what. If I have y equals kx, which you know is going to be a line, y equals kx squared, which will not be a line, but we'll talk about it later this week, y equals kx to the third. No matter what, these all go through the origin, 0, 0. And this is the other thing. 1 comma k or 1 comma m is always on the graph because of rise over run. So if you have just a graph and you're trying to figure out that equation, if you go to the where x equals 1 and go up to your y value, that will be the same as your slope or your constant, your variation constant. Your other option could be the way that they used to teach you is to find 2 nice points and figure out what the rise over run is. Okay, so those are from the activity. We will talk more about that when we do the activity. And that's all I have for you. Time to hit the slopes. Quick notes section. Probably could get started on that homework if you want. See ya.